COMSOL Multiphysics Lecture 7 Prestress Effect in Eigenfrequency Problems or Natural Vibration Problems. Open a part file. We'll draw a CD plate. On XY plane, enter sketch mode. Draw two circles, concentric circles. For the inner circle, the diameter is 10 millimeters, and for the outer circle, it is 120 millimeters. And we'll extrude it to 1 millimeter thick. So this is the CD plate. I'll save it on desktop. Now, first of all, make sure that the software is loaded here. And then we'll enter COMSOL Live Link. So make sure that the Live Link option is toggled on. And we'll open a COMSOL procedure. For those who have a slower computer hardware, I suggest that you use Live Link mode instead of docking mode. Define a 3D problem, a solid mechanics. COMSOL has written a procedure for prestress natural vibration. So this is the prestress analysis option for eigenfrequency analysis. So we'll choose that. Also, you can choose eigenfrequency and stationary solid static analysis. So if these two are chosen, the effect will be the same as prestress eigenfrequency problem. So we can choose this one and click done. And first of all, we will load the 3D part here. So we finish with the first step. For the second step, material, I'll choose PC or polymer polycarbonate, but there's no polycarbonate. I'll choose acrylic instead. Make sure that the geometry is linked with the material property. Mesh, finer mesh, builder mesh. And for boundary condition, I'll choose fixed constraint and choose the inner surfaces, surface 5 and 6. And this will be the constraint. For the load, I will apply body load, but it is not here. So this is volume force, and there will be body load, gravity, and rotating frame. And I choose rotating frame. You can also select physics domain load, and this will be body load, gravity, and rotating frame. I can choose this one. So I'll select the CD plate body, the part, and the rotating axis will be z-axis, and it is counterclockwise. I'll use angular velocity, but the unit is radian per second. It's very hard to use, so I change it into RPM, and I enter 60 RPM. So it is very low speed. Coriolis force is not presented in this problem, so I'll go ahead and choose how many. I'll enter how many vibration modes that I need to calculate. So this will be 6. And so this is a rotating speed problem. So I'll go ahead and run the study. Go back to home page and compute the procedure. This is a very slow rotation of 60 RPM. And after we finish with calculation, we will compare the frequencies of lower rotating speed with higher rotating speed case. So we can understand how the prestress affect the natural frequency of a structure. So now we can see that for the structure right now at a rotating speed of 60 RPM, the frequency is 73.3, right? So now we'll change the rotating speed to 2400 RPM and run the calculation again. Remember that at a lower rotating speed of 60 RPM, the natural frequency is 73.3. At higher rotating speed, a higher prestress build up in the compact disc. So the internal stress of the CD increases. So the CD become more rigid or more stiff. Therefore, the stiffness or the rigidity of the structure increase, and also increases the natural frequency. So now you can see here that the frequency has increased from 73.3 to 84.4. So now again we can see from the result that for vibrating system, if you increase the prestress, it will increase the frequency by increasing the rigidity or stiffness of a structure. As we said before, that the external force do not affect the natural frequency of a structure. But how? Again, here the rotating speed generate a external force, right? But the external force actually increase the internal stress of the structure, and the internal stress will increase the rigidity or stiffness of the structure, and thereby increase the natural frequency of the system. So the external load, although the external load does not affect the natural frequencies, because the external force term appear on the right hand side of ordinary differential equation. But once the external loads generate a substantial increase in prestress or internal stress, the stiffness or rigidity of the structure will increase, and thereby increase the natural frequencies.